think we're going to get started. Thank you for coming back in from the 80-degree weather overlooking the lake. This is going to be worth it. It's my great pleasure to introduce Jane Addams. She actually self-introduced herself a little bit before. She's an artist, designer, turned computer scientist, currently getting her PhD at the Data Visualization Lab at Northeastern University. And I think she already told you that she holds bachelor's and master's degrees in fine arts from Champlain College. And if you got to hear her talk earlier today, I think you already know that she's a fantastic speaker, so this bodes well for this workshop as a teacher. I think she has this amazing ability to kind of seamlessly move between learning, teaching, and actually using these generative tools that she talked about earlier. And she does this using art as a medium, but she goes from no coding languages all the way up to these GANs, these generative adversarial networks that she talked about earlier in Python languages. So with that said, her practice creatively blends the emergent media from these technologies with natural phenomena such as plants, fungi, weather, geology, basically to celebrate the beautiful relationship between science and the arts. I've actually had the pleasure of hearing her give a number of talks during the 3 years that she was I loved your title, visualization, data visualization artist in residence for the 3 years that she did that for us at the Vermont Complex Systems Center at the University of Vermont. And so I find that whether she's presenting or teaching, she has this amazing ability to find a commonality with students of all ages, including those of us with white hair. So without further ado, no, you're not. Beyond text to image, take it away, Jane.
Testing? Cool. Thank you so much, Donna, for that incredible introduction. And thank you all for coming back inside on this beautiful day. I'm so sorry to keep you away from the sunshine. It means a lot, and so I really hope that this is a helpful workshop for you, regardless of whether you are, as I mentioned before, self-described, not a computer science person, or you're an expert in AI and maybe you know more about it than I do. But I really hope that this workshop kind of covers the gamut of tools that could be useful for anyone. And I think it's also well informed by my experience as a graphic designer, and so you might actually see some tools from the world of design in this workshop that maybe you wouldn't see in most other AI workshop pipelines. So this is not a workshop about text to image, so you won't find any DALL-E, Midjourney, or Stable Diffusion here. I think that those tools are great, but part of my interest and excitement as an artist is in curating my own data sets. Jen Carson, I believe, is here, maybe teaching workshops right now, but her Instagram handle is actually Own Your Data Set, and I think that we share some enthusiasm actually for the laborious, sometimes tedious, but deeply meditative process of curating, collecting your own data to make your own AI models. So if you missed the morning talk, this is just a brief refresher on the idea of generative adversarial networks. So you have two neural networks in conversation with one another, a generator and a discriminator. Generator is generating images. The discriminator is the one that has seen the real images and is basically judging whether something is real or fake. And the two of these networks go back and forth for a long time, deciding, is this real, is this fake, and they both get better at their job. So the generator gets better at generating images, the discriminator gets better at deciding what's real and what isn't. And over time, they're able to produce some really convincing images based on training data. So this is kind of a deep simplification of the process of training your own generative adversarial network, specifically talking in this talk about StyleGAN, which was really the way that you made AI art prior to the explosion of text-to-image models over the last 18 months or so. So basically the process is very simply to collect a bunch of data, train a model, but then there are some other kind of secondary steps that might happen along the way. So you might collect a bunch of data, make adjustments to it, do some pre-processing, transformation of that data before training a model. And then when you train that model, you might find actually that it has not created at all what you intended it to, and that you need to refine some inclusion parameters, and then either go back to the drawing board of collecting data or reconsider how you're processing and transforming that data. And then once you've trained your model, you might also want to apply some processes or transformations to the output of that model. So to simplify, data, train, output, and then along the way, we might do some transformation, we might do some revision, and we might do some stylization. So to kind of keep us grounded throughout this talk, you're going to see this diagram up in the corner, and I'm just going to highlight where we are in the talk. And also, at any point, if people want to raise a hand and interrupt, feel free to ask a question, but I'm also going to leave time for questions at the end. So I hope this is useful, and also I think it should be possible, right, that we could share these slides afterwards so that people could access them. Cool, so we'll do that so you can re-reference when you start exploring yourself. So first, talking about the data part. There might be a couple questions that we want to answer. What makes data good? Where do I find data? What about creating data? And what does it mean to ethically source data? So what makes data good when we talk about what kinds of data we want to collect for a generative adversarial network? So a couple of things that I noticed in my process was shared visual motifs. So if you have a data set, so for example, this is a model that I trained off of stock photos of raindrops on glass, which is a very large repository, I guess because of the editorial versatility of raindrops on glass. You know, it could be the joy of spring, or it could be a dark and stormy night. It could be a melancholy look out the window as we, you know, dream of being by the lake. But having shared visual motifs in images really helps when you think about creating a model and specifically creating videos like this, which are linear interpolations between representations that the model has learned, that if it has some kind of commonalities across images to sort of link onto, it makes it a lot easier to create these kind of nice flowing conversations between different points in high-dimensional space. Whereas if you have a wide diversity of images when you're training a StyleGAN model, the output videos that you create can have some really abrupt changes, or your model could experience something called mode collapse, which we'll talk about in a little bit, where it just kind of doesn't settle on anything because it doesn't have any consistency across the data. Other things that are important to consider: dynamic composition. So this is, you know, something to consider whether you're making AI art or you're painting in a studio, but thinking about the shapes that exist in your composition, the conversations between colors in a composition, having depth, having atmospheric perspective, all of those things that make works of art interesting to the human eye are also really useful for adding some interesting visual elements to a generative adversarial network. We also need to fit model constraints. So you have to consider basically, like, depending on which model you're using, maybe it only uses square images. And so even if you're collecting landscape and portrait images, you may know that they're going to be cropped later, and so you want to consider that when you're collecting the images. And then also alignment. So this was some training data from a model that I trained on my own face. And the first pass had done a terrible job. It was very deeply disturbing, actually, what I created. And so the second time, I actually had to go through and do some pre-processing in order to find my own eyes in the picture and align the eyes so that they were all in the same place. And that really helped to make it a little bit less of a horror show. So where do I find data? This is a great question, and the answer is everywhere. Whether it's good data or not, we just talked about. You might want to make some considerations there. But here were a few resources that I found useful. If you've heard the term API before, you might have heard it thrown around like a lot. And it's very confusing at first, but basically, fundamentally, an API is just like a URL where you can get data. So you go to some website and maybe they have some documentation about how their API works, and you may have noticed this as you're browsing the internet. You'll have like a little question mark, and then you'll have all of these variables, and it'll say user equals and some alphanumeric string, and number of clicks and number of posts and things like that. Well, you can actually use that data to communicate with a data structure on the internet and get information back. So a lot of companies will set up APIs, which stands for Application Programming Interface, to access data. And so for some of these models that I trained on stock photographs, Pexels and Unsplash are royalty-free stock photo websites that actually provide a whole bunch of documentation about how to use their API, and you can download data directly from that URL. Python and Beautiful Soup are also really great for scraping. I really love Python as a programming language, especially as an intro spot. So if you haven't coded before, but you're kind of thinking about diving into it, I find that it can be very accessible and very kind of easy to understand and experiment with. And also has just an incredible wealth of libraries available for data processing and things like that. Beautiful Soup, if you are a Python user, you might already know this. Beautiful Soup is a library specifically for parsing HTML. So if you have a website that doesn't have an API and you want to pull some data off of it, Beautiful Soup can be really useful for kind of breaking up HTML code, which decides what gets displayed on the browser, and actually extracting metadata that you want for your model. There are also a ton of browser extensions for bulk downloads, and so that can be another way of a no-code way, notably, of getting a whole bunch of images from a website. And then also database searching. So GitHub, the Internet Archive, research publications, just have an incredible wealth of information that's really useful. What about creating data? So not only can we source data, but we can also think about how we could bring digitized information into a digital space in order to train our own model. So some notes about creating your own data. One is be consistent. So I have some pictures of flowers here, and you can see they all have a black background. If you were to introduce some pictures with a white background, then all of a sudden you're going to have your model sort of trying to decide between, does this have a black background or a white background, and you might have some dramatic shifts between those two. So being consistent in the way that you lay out your images or in the criteria that you use to collect or create images is really important, and also related to the conversation we just had about visual motifs. Also, reduce overhead. So some of the best human inventions have been the result of sheer laziness. I don't think that's going to change anytime soon. So as much as you can reduce the amount of time that you are wasting doing the same action over and over, the better. So here's just an example of a stamp collection where rather than scanning every single stamp on its own, someone has tessellated these stamps onto the scanner bed, scanned one image at once, and then gone through digitally and extracted them instead. And anyone that has used a scanner knows, like, one of the biggest, overhead costs there, if you're scanning individual stamps, is just the sheer amount of time that it takes to go forward and go back, and alignment and all of that. Also, in creating data, consider secondary usage. I put some birds up here because I don't know if anyone else does amateur ornithology, but could be an interesting opportunity to consider. If you're collecting all of these images because you would like to create a model that can generate images of birds, maybe there's a research arm somewhere nearby that could actually really use some more photos of birds and trees around here in Vermont, or something like that. So maybe consider secondary usage, and communicate with your local community and say, hey, are there data collections that don't exist yet that should exist, that would also be a good opportunity for me to learn about how to curate a data set for an AI model. And then also use transformation as a step to clean and or increase size. So I'll go over that a little bit more in a bit. What does it mean to ethically source data? This is a big conversation, and I don't think that it has been a decided conversation yet. There's a lot of voices, a lot of conversation about this. And I really think that it could be a great opportunity here today for people to also talk through sort of what their feelings are on ethically sourcing data. And I think it's a very important conversation also related to labor and compensation. So we really can't have these conversations about data or about authorship or about credit without also necessarily, unfortunately, talking about economics, and talking about capitalism, and talking about labor and compensation and things like that. So there are a lot of really good resources out there. Here were just a couple kind of notes that I've come across in my research. So for extra reading, there's a zine called Making AI Art Responsibly from the Partnership on AI, which talks all about the data set, the model code, training resources, and publishing. Some other notes of my own that I had were to consider the compute strain and financial costs. So there's something called DDoSing, which is direct denial of service attack. It can be done intentionally. Say you want to take down a website by just flooding it with too many requests, and that's something that we see often in like hacker movies. But oftentimes websites also get DDoSed entirely by accident. So if some new product comes out, or some new health portal opens and everyone goes to sign up all at once, that can also be a distributed denial of service attack, kind of unintentionally, that can take down servers. And so when we think about collecting images, you also have to be cognizant of the fact that, especially when images are coming from a place, say it's an academic institute that has shared these images because they want them to be publicly accessible, but they were thinking about it in terms of a user downloading maybe 1 or 2 images every 5 minutes, and you've gone and scripted to download their entire website in a matter of seconds. That could potentially put a lot of strain on their computational resources, could cost them a lot of money. So there are ways to kind of go about that, either by contacting or by planning your scripts to scrape in a slower manner that can consider that compute strain financial cost. Another consideration is, what is the provenance of the data? So maybe you want to train a model to generate medical images because it would be really cool to have, animations of brains changing kind of all over the place, and it would look great for your music video. But maybe, like, what is the provenance of that data? Because if you are just looking on the website for x-rays and MRIs, and you're checking GitHub repositories, and you're using all of these image search things, you may find that actually there's sensitive personal health information in that data, and maybe it was uploaded to the website unintentionally. And so really thinking through what the provenance of the data is, how it got to where it was, if it's supposed to be there, is important. Also assessing dataset diversity. So for anyone that's familiar with Sophia Crespo's work, she's an AI artist who does some really incredible stuff with jellyfish in particular is one series of hers that I really love. And she gave a talk at MIT Future Sketches a couple weeks ago where she talked about a frustration that they had when they were collecting training data for that model is that the only pictures of jellyfish on the internet are really adult jellyfish. And I had no idea, but jellyfish go through like 6 or 7 different stages in their life cycle. And so she noticed in her model that they were actually only representing one of those life stages in the model, and that it could potentially do a disservice to understanding of jellyfish life cycles everywhere. Now that's kind of a fun natural science example of that, but there are also more serious considerations to be made when we talk about data sets that use humans and diversity there, because we know that statistically speaking, some data sets or some models can actually not only replicate biases, but exacerbate them. So you might have a data set that is 60% one demographic and 40% another, and a model could learn representation in latent space that produces 80% that demographic and 20% of the underrepresented demographic. So another consideration to make. And then finally, what is the destination? Like, where is it going? What are you creating with this? What's the purpose of it? How will people interpret it? Who's going to see it? How will that make them feel? Those are all important questions too. So what kinds of transformations might I want or need to apply? Those could include things like cleaning, filtering, stylization, or artificial data set size inflation. So I mentioned before, it can be very laborious to collect all of these images, and yeah, I'll get to that in a second. So in terms of cleaning, as I go through this talk, you might also see, like in the bottom left corner here, some like icons of software websites and things like that. Those are just references for later if you're like curious of ways in which you can do some of the suggestions here that I found useful in my process. So one of the first things in the cleaning step is to remove duplicates. So there was this really awesome paper, which I've linked here, that came out, I think, in November or December of last year, talking about memorization. So something that was a really common response to critiques about data sets and transformative use was that, these generative models are never actually learning or never actually replicating their training data. They are always creating some collage, or they're always blending things together, or it's a representation of a probability distribution. But something that this paper found, and a number of others actually, is the idea of memorization. So this can happen when you have duplicates in your training data, especially a lot of duplicates. You see Mrs. Doubtfire here and Garfunkel and Oates. It's a comedy duo. Images that show up a lot on the internet can oftentimes kind of poison a data set and end up being memorized exactly. So on the top row here, you see the original image, and on the bottom row, you actually see the generated image. And you can see that they're almost pixel perfect representations of the training data. So that's a good reason to make sure when you're collecting your own training data to go through and remove duplicates. And that could be an automated process that might also involve some manual checking. Another step is to delete low resolution images. Here's a high resolution image, here's a low resolution image. Low res images can cause some really bizarre artifacts in GAN models, and maybe that's what you want to do, but oftentimes it's not. I ran into one issue where I wanted to create a model that would generate fire, and I found this really great data set for computer vision for fire detection in kitchens. So they were deploying it in fast food context to detect when something was on fire in a fast food restaurant. But it turns out that detecting fire from an image actually doesn't really require super high resolution images, and that it's much easier to train and share these models if they're operating on a lower scale. So using that training data as my fire image just created this model that like fundamentally was just creating like big blocks of pixels that were vaguely red and gray. Another consideration is to be careful with file types. Like StyleGAN, for example, I think they fixed this in StyleGAN 3, but I think in StyleGAN 2 it was an issue. It would ingest PNGs that had an alpha like transparent pixels, but then it would end up sometimes breaking the model, but sometimes it wouldn't be until it had like gotten to that image. So you might be training for a really long time before that one thing kind of clogged your pipe and burst your whole system. And so it's important when you're, walking through transformation to think about cleaning data. Maybe you just want to add a white background to things that are transparent. And then also in cropping, so I trained another model where I was using images that were just a straight shot down a road. And it was a square StyleGAN model, and so I just created this script to automatically crop right in the middle of the image. But as you can see on the left here, it's cropped fine because the vanishing point is in the middle. But on the right, because of the dramatic photographic composition, we actually have the vanishing point is not contained within the crop square. And so that necessitated actually going back and finding a way to identify the vanishing point in the image before cropping. Filtering is also really useful. So that could be manual filtering, but that could also be things like, for example, I trained this other model using color selection. So the first version of the model that I had trained, I found that it was like a mixture of a lot of different colors, and what I actually wanted to access was just the landscapes in the training data. And so as a proxy for that, I basically used k-means pixel clustering and set some arbitrary number. I said 5, and I said, okay, find me the 5 kind of centroids of color that are represented in this image using hue, saturation, and lightness. And so from there, I was able to pick out which colors were most prominent in the image and then filter to a specific hue range. So I said, only give me things that are somewhere between slate blue and lime green, because I want images that are, skies and ocean and trees. Metadata analysis is also useful. So some of those APIs that I mentioned before also include metadata, for example, caption information or geolocation or categories for tagging. So that can be a useful way of filtering. And then subject detection or image segmentation. So a lot of these are used for computer vision, for selecting a specific object, but can also be really useful for filtering. So you can say, I only want pictures of cats and not pictures of dogs. And there are a lot of libraries that exist out there for subject detection and that can segment images. Also, in terms of transformation, stylization can be really useful, both for editing and also for data set size inflation. So there are models out there that can do time of day or seasonal translation. So if you only want landscape images that are in the winter time, there are actually AI models that can convert your summer images to winter images, or that can convert your daytime images to sunsets or your nighttime images to daytime. So that can be another way of transforming your data to kind of steer your model in a different direction without even beginning the training process. Another one is style transfer or image filters. So maybe you want a very painterly model, but you want it to be of a specific kind of architecture, and you don't have enough paintings of this particular architecture that you want. And so you might want to apply something like style transfer to, say, give me this architectural style in the, or this architectural style in the style of Picasso, and use that as your training data. Another one is alignment. I mentioned that face model before where I was trying to get my eyes in the same place. Another model that I created that was the stuff of nightmares was a hand model that used left and right hands, and so there was just a lot of like this happening. And so the second time that I worked on that model, I set it up to use metadata to identify whether it was a left or right hand, and then I flipped all of the hands so it would still oscillate between whether it was your palm side or the back of your hand side, but at least the fingers were in the same location. So it was a little bit more of a subtle undulation into the uncanny. And then finally, background removal. So I trained another model that was, it was a model. So it was using fashion models and removing the backgrounds of those images in order to really just focus on the main subject. And I also did that using subject detection, which I mentioned on the previous slide. So another transformation that we might need or want to apply is artificial data set size inflation. So you need a lot of images to train these models. So generative composition was one that I really enjoyed. What we see up in the left corner here was I wanted to create this model that could replicate potted plants and that would actually interpolate between a cactus and an aloe tree and a fig tree and a bouquet of roses. And I got a whole bunch of potted plants, but I still didn't have enough. It still wasn't quite where I needed it to be. But in the process, accidentally actually, as I was removing backgrounds, some of my plants were in white pots, and the background removal process took the pots away when it took the background away. So I had all of these poor plants that had no pots anymore. But then this idea occurred to me that actually it was wonderful because I had all of these plants and I could get pictures of pots that didn't have plants in them, and I created these plant pot adjacency matrices. So I basically had a row of pots and then a column of plants, and then digitally potted them in Adobe Illustrator such that you had all of these different permutations of, a cactus in a high blue pot and an aloe plant in a low terracotta pot. And it was a great way of increasing my data set size, not linearly, but actually from end to end squared very quickly. Also, rotation and mirroring can be really helpful, especially, this only works actually for data sets where rotation and mirroring doesn't matter. But you can see here for my maps model, because I was taking these maps out of context, I actually made a Twitter bot to tweet the training data. So if you ever want to check out maps out of context on Twitter, it's like sharing those. But I decided that I didn't actually care about orientation. North-south doesn't really matter for the model that I was trying to create, because it was just more of the feel and the colors of the maps that were in the training data. That would be a sufficient way to increase the training data size. You can also use generated images as inputs, so almost using your own kind of evolutionary process. So this was actually a model that I trained on microscopy images and biology images, and I was particularly excited by two different types of images that I saw a lot in the generative outputs. One was this kind of mycelial texture, so there were these like wispy kind of tendrils like coming off of mushrooms almost, that I really liked in the data. And then another was this more sort of like goopy, vacuole, like cellular matrix type composition. So from the output images, I kind of collected new training data that I wanted to use and transform and duplicate in a new model. And then also cropping. So this was also from that map model that I worked on. These images are huge, so it's actually the opposite of the resolution problem I talked about before. These images are like 72,000 pixels wide sometimes, but you can actually get some really high fidelity images by cropping to a much smaller size. So from a single image that's downloaded from the repository, you might get 6 or 7 or 8 smaller compositions. I'm going to pause here for a second. Any questions so far? Yeah.
I'm just curious, with all the tools for each of these steps, were like most of those kind of already in your toolbox, like Photoshop and all these other things? Like how much of this craftsmanship development, like do you find like having to spend to learn new tools, or just like diving in kind of into your practice with that knowledge or skill already?
Yeah, that's a great question. So I'll repeat for the cameras. So the question was, how many of these tools that I'm using in data collection and transformation already existed in my toolkit, and how many did I have to learn afresh? And it's funny because now that I think about it, the line starts to blur where I don't really remember at which point I learned different tools. But I'll just go through some of them quickly. Processing was actually how I learned to code. Because it was the first time that I had a code representation that also allowed me to interact with variables and change them. And even if I didn't fully understand what everything was doing, I knew that if I changed this number, it went from red to blue, and that was helpful. Adobe Illustrator I had used a ton in my design work, but I really it was actually probably the tool that was most readily accessible to me because it was so familiar. I'm sure that there are other cropping tools that people are used to using in their daily life, Mac Preview. You can just Control K in order to crop out an area. So maybe that would be the fastest for someone else. I found that Illustrator was nice because you could do multiple crops at the same time using artboards and then just export. Bash scripting was something that I really learned purely out of frustration and need to automate things. Maybe laziness was where I just, I needed to sort images really quickly, or I needed to rename files quickly. And every time that I Googled how to do that, the internet kept telling me I needed to open my command line. And finally I was like, okay, I guess I'm going to learn the command line. Adobe Lightroom was something that I hadn't used previous to doing this work, but I had a lot of friends who were photographers who recommended it for kind of applying bulk light changes. GitHub repositories I was familiar with. Runway ML was kind of my intro into AI before I started doing any coding related to it, because it's a totally code-free, what you see is what you get type system. Collab notebooks was also something that I was kind of pushed into by necessity, and peers on the internet being like, you can just do so much with it. It's worth, figuring out how to struggle through the complexity of the system, and a really great way to access other community notebooks and chunks of code and things like that. And then Photoshop I had used for forever, and I had no idea about batch actions. So Photoshop batch actions are you can basically record yourself doing something like cropping or applying a filter or something like that. And then you can save that recording of whatever you did and replay it on a whole file system, on a whole set of folders, and automate a whole bunch of stuff. So that was something where it was a familiar technology, but a totally new application of it. So in terms of training, lots of questions. How do I train a model? How do I choose which model? How much does it cost to train a model? How do I troubleshoot? These are scary questions, especially if you're just first diving into AI and generative technologies. But there are also questions that I think the answers to them are evolving so rapidly that probably what I added here 3 days ago is already maybe a little out of date. And I think one of the challenges here is is more about like how to find resources. So I'll go through kind of what I know, but with the caveat that like there's so much out there to stay on top of that like I can't possibly touch all of it. And I really encourage people to think about what they want to create and really go searching for communities that have tools that support that specific type of visual representation or data structure or something like that. So some tools for training a model. Runway ML, as I mentioned, was kind of the first way that I dove into this. It's a no-code machine learning lab. You can do all kinds of fun stuff with it. You can train your own style GAN models. You can apply style transfer, which is what I showed before, like applying Picasso to a new architectural style. Google Colab is Python on Google GPUs, so you have access to high performance computing type stuff, but then you also have the ability to work in a familiar format. If you've done Python programming before, you might be used to the Jupyter Notebook structure where you like run a cell of code and then you have some small output, and it's a very nice way of debugging and also sharing your code. Replicate I only recently learned about, but this is APIs and cloud compute for community models. So this is like basically a wrapper for different model code and allows you to use their infrastructure, but then also kind of be more customizable with your workflow pipelines. And then there's all kinds of custom setups using PyTorch and Jupyter Notebooks and AWS. You could also try to kill your laptop. I know lots of people that have trained their own style GAN models on a laptop computer, and it can take a month. But power to them. Some people it's more about the process and the struggle and the labor that's involved than necessarily efficiency. So whatever floats your boat, depending on what your objectives are and your needs for customizability. How do I choose which model? This really depends a lot on what you want to do and what's out there, because there's new things coming out all the time. I really love survey papers and research. So survey papers are just academic papers that are kind of meta. So rather than introducing a new technology or a new model, they basically look at, what is the state of the art today and what are the affordances and drawbacks of each of these things. So when I share these slides, you can look at this one in particular, has a great kind of look at all of these generative adversarial networks and says, some are data efficient and some of them are good for conditioning, and some have different features of them in terms of the way that they're structured. Also consider your subject matter. So I'll talk about transfer learning in a little bit, but basically like some models, when they come pre-trained on certain data sets, for example, StyleGAN2, one of the data sets that was pre-trained on was FFHQ, which is the Flickr Faces data set. So that pre-trained model in particular does really well with faces. So if you want to generate new faces, even if they're of a different style or a different subject matter, that might be a good place to start. So thinking about what the original training data was and how much that is different than what you're trying to do. Also, what parameters are priorities? So a friend of mine, Mikhail Alafritz, designed Lucid Sonic Dreams, which is a notebook, and I think now also is available through the Replicate API for basically creating latent walk, those animations, using audio also. So if you wanted to create a music video and you wanted to have sliders that could adjust based on the pitch or the drum beat of your music, then you would really want to look at a very small subset that can work with parameters related to audio. And then also try a lot, like experiment. The worst that can happen is that you waste a bunch of time. But I think it's a really fun space to explore. And you may be actually surprised with the way that models respond to the inputs that you give them. How close are we, Chris?
We're a little over, but keep
Oh, okay, sorry. I will share these slides afterwards so that they can be used afterwards. But there's always going to be trade-offs in terms of cheap, easy, customizable. It's kind of like pick 2 of 3. And so you sort of have to decide what your priorities are there. And then for troubleshooting, definitely rely a lot on community resources like forums and chats. Visualize your data as a debugging process, and also consider approaching from a different angle. So, there could be multiple ways to look at the same problem. You may need to revise training data. So you might have unexpected results, mode collapse, as I mentioned before, or you might want to just move in a new direction, or you may have missed a cleaning step. Transfer learning is a great way to take a model that already exists and kind of move in a different direction without wasting a whole bunch of time and compute resources to do so. And then once you've trained, you might want to do some stylization. So that could involve things like applying style transfer to outputs, cropping, outpainting, chroma keying. So chroma keying is just green screening. This was that fashion model that I mentioned before, where I wanted the output video to also have a transparent background. So I actually put a green screen in and then removed it in post-process. Or also thinking about framing and collage, things like that. There's such a thing called ESR GAN, which is a GAN that specifically has learned to upscale things. So you actually can now enhance using the computer like they do in sci-fi movies. Lots of resources, code and no code for doing that. And as I mentioned before, Photoshop batch actions are really great for bulk changes. On Macs, Automator is also good for bulk image processing or scripting file names, that sort of thing. But there's also lots of resources that are code-based. Those were just 2 I wanted to share that are no code. And then in terms of output, we've seen a lot of presentations from artists on different ways to output images. So just a couple that I've been enjoying: projection mapping, video collage, 3D objects, sculpture. Once again, please stop by BCA if you haven't seen the exhibit yet. And textiles is something else that I've been working a lot with. So I'll stop there. I realize I'm over time. Sorry about that. But feel free to come up and chat with me afterwards if you have more questions.